Hello everyone, my name is Alan and my project is called Breathable Density, Passive Cooling for High-Rise Living in Hong Kong. It aims to reimagine what sustainable high-rises could look like in the year 2050. Next slide, please. Next slide, thank you. First, a little overview of the context of Hong Kong. Next, please. Hong Kong is located on the northern coastline of South China Sea. According to the Köppen climate classification, it is considered hot and humid subtropical, with a high horizontal solar radiation throughout the year. So the main environmental challenge of Hong Kong is staying cool. Next slide, please. Hong Kong is known for its highly dense urban population in an extremely small landmass. As a result, high-rise apartments became the dominant housing typology, making up 96% of all residential buildings. Despite the incredible densities they achieve, these solid extrusions created a tight urban morphology that is unable to ventilate effectively. This further increases the urban heat island effect, causing higher temperatures in the city. Next, please. More than 60% of Hong Kong's carbon emission comes from energy use of high-rises. As the inner city becomes hotter, people rely more and more on mechanical cooling to stay in comfort. This growing appetite for energy consumption is causing the acceleration of global warming. Hong Kong is expected to have a temperature increase of 1.5 degrees to 3 degrees by 2050. As such, there is a huge incentive and urgency in finding alternative methods to stay cool through passive building designs rather than relying on mechanical systems. Next, please. Next. So what if buildings are breathable and can open to the outdoor environment instead of fully enclosed? Can we redefine what programs need to be air conditioned and what programs can be semi-outdoors or outdoors? These questions are further explored through the investigation of passive design principles, such as solar protection, thermal buffer, and ventilation control. Next, please. Here, I will briefly go over the preliminary massing development. Next. The project site is located in the northwest of Hong Kong Peninsula, next to the Victoria Harbour. Next. The proposed podium geometry is designed to minimize ground coverage and maximize permeability. Next. The proposed tower responds to the surrounding context by shifting the mass away from the neighboring building to minimize daylight obstructions while achieving higher density. Next. The tower is then deconstructed into smaller segments with an open atrium to allow for stacked ventilation and prevent wind obstruction. Next. Floor plates are pushed and pulled to create self-shaded facades that protect itself from harmful direct solar radiation. Next. And finally, decentralization of shared programs allow for truly mixed-use functions, threaded by vertically integrated green spaces. Next. The effectiveness of the passive strategies are further supported through various environmental analysis. Next. First, irradiation mapping is simulated to show a 240 kilowatt hour per square meter reduction of direct solar radiation on vertical surfaces through simple manipulation of building geometry. This means integrating shading elements such as overhangs and louvers can drastically minimize unwanted solar heat gains, thus lowering cooling loads. Next. CFD analysis is performed on the proposed tower at various scales to test ventilation effectiveness. On an urban level, a minimum of 3-meter gap is needed to allow more wind to penetrate the tower and enter the city. The tower is designed with breezeway atria that are cooled and ventilated through thermal displacement. And all units are designed with dual aspects in mind, allowing for effective cross-ventilation, and therefore reduce the need for mechanical cooling. Next. Lastly, thermal energy analysis is performed to determine which passive strategies can be effective in different seasons. The proposed design is estimated to reduce the annual cooling consumption by 75% when compared to a typical Hong Kong dwelling, allowing the building to be free running most of the year with a mixed mode strategy introduced during peak periods in the summer. Next, please. The 3 unit types are standardized to accommodate for Hong Kong's most demanding housing sizes. Additionally, the push and pull effect of the floor plates create private balconies, allowing occupants to create informal outdoor functions. The outdoor vegetations also help create a comfortable microclimate, absorb CO2, and filter fine particles. Next, please. The floor plans are also designed with modularity in mind to allow ease of construction and flexibility in unit configuration. Next. The tower contains 6 unique vertical community clusters, and cross-laminated timber is used as a main construction material as it is very low in embodied carbon when compared to more traditional materials such as concrete and steel. Next, please. To rekindle Hong Kong's traditional neighborhood living, communal programs are vertically distributed based on solar orientation, circadian living, and ventilation needs. Next. Outdoor comfort strategies are implemented, such as movable facade panels and shaded walkways, allowing activities to take place all year round. These transitional spaces function as connecting elements that extend the occupant's activity from indoor to semi-outdoor to outdoor. By designing with flexibility in mind, the proposed tower can adapt to Hong Kong's unpredictable climate scenarios. Next. So in closing, this project aims not only to address immediate environmental issues of tall buildings, but to also reimagine a new high-rise standards with a strong focus on improving quality of urban life and cultivating a climate-resilient future. Thank you.
Great, thank you for sharing. I'm going to now ask all the jurors to unmute and turn on their cameras. And then Alan, keep your camera on and mic on when you're ready to answer their questions. So thank you, jurors, for joining. When you are ready, you may begin asking questions. You have 5 minutes, and if for some reason 5 is not needed, we'll move on to the next presentation.
Okay, so just to clarify, Abby, it's just questions, not comments. Is that correct?
You're more than welcome to give comments as well. Yes.
Okay, I'd probably really like to start with the comment, Alan. Thank you so much for an excellent presentation. It was very comprehensive, and I particularly liked the way that you covered not only the environmental aspects, but the social aspects of improving livability in Hong Kong and thinking about the way people live in that city and looking at a new model for the future. I also was pleased to see that you actually had modeled to benchmark the qualitative and quantitative features that you had put in the building. I don't actually have any specific questions, but I'd just like to offer that feedback. So maybe I should pass on to the next, maybe Craig's got his mic off. So maybe Craig, I'm on, sorry. So maybe Craig, do you have any questions?
I do. Yeah, thanks, Helen. That was great. Breathable, fantastic, and self-shading, very good. Use of timber. I've got 2 questions. Use of timber. Did you make any consideration of the durability of the timber? There seemed to be a lot of exposed timber there, and clearly it's on a it's on a waterfront environment and very exposed. Did you give any consideration to longevity of timber in that situation?
So the entire tower is it's a I'm using a hybrid material, a mixture of reinforced concrete and heavy timber. In terms of the durability, from what I have read, it's there are ways of treating heavy timber when it comes to humidity exposure and things like that. but I haven't looked extremely in detail on that aspect.
Yeah, there are ways of doing it. And I've got one follow-up question, Helen, if I may. In terms of the atrium and air coming up through the building and the CFD work that you've done, very, very good. I just wondered if you thought about profiling the top of the building to maybe accentuate the flow of air in a sort of low wind situation. You might be familiar that some buildings have scoops on the top to actually accentuate that effect. I just wondered whether that was part of the thinking and whether you felt that was something that that was explored or could have been explored.
Right. Yeah, I think that's a very good point. I think because of the site I've chosen, which is near a body of water, there it is actually quite a windy site. So I'm trying to it's kind of a balance of allowing wind to permeate the building into the city, and also on in terms of vertical microclimate, allowing the balconies to be comfortable, so that the folding facade actually kind of breaks up some of the stronger winds. Yeah, things like that. But no, I don't think I've considered the wind scooping effect for this project.
Thank you.
Thank you.
Viviana, do you have any questions?
First of all, congratulations. The presentation was very clear, a lot of very simple diagram that explain very well the concept. I particularly like the work that you have done on the initial massing and how you went from, you know, a simple extrusion of the building to then demonstrate by thermal and fluid dynamics how your proposal is actually valid from, you know, responding to the local environment. So well done for that. The aspect that I think it's that you might have considered, and that's my question really, is one of the big issues that I find in Hong Kong that I visited many times in the past years is the overlooking issues. Meaning that, you know, from an hotel room or an apartment, you can always look into somebody else's affairs. So I was wondering whether you had thought about this, because, you know, the living or our house is always, or flat or whatever, is always, you know, this private, or we try to tend to imagine it as our nest private environment. And how do you overcome one of the big issues that are in Hong Kong with the proposal that you have, you know, creating a breathable building?
Yeah, I think in the context of Hong Kong, because the buildings and the towers are so closely built, privacy is definitely one of the bigger issues. That's why for this project, I think it's really important to showcase that human-centric design is very important, in the sense that having automated system is great, but I think there needs to be an overlaid with occupant controllable, operable things, such as, you know, windows, blinds, things that are more accessible for the individual, because everyone uses their homes differently. So maybe some people do like the more social aspects of, you know, sitting on a balcony, you know, having a cigarette, or, you know, doing the laundry and talking to other people, but others might be more private, right? So I think when I try to design the units, there's definitely an element of user flexibility that needs to be integrated. So I don't know if that answers the question.
No, glad. Thank you very much. That's our last question for this session. I will ask all jurors to then mute their mics and turn off their cameras. And then Alan, you can do the same as well.
Thank you.
The next project presenting is a critical approach to vertical graveyards. When you are ready, please turn on your camera and mic.
Hello, I'm Nikita, and I'm excited to share my project. Architects are researchers by nature, and today as never before, they grapple with certain millennium problems, challenges of verticality, affordability, sustainability, in aggressively expanding urban fabrics worldwide. A significant aspect of this new urban life cycle, graveyards, has been majorly out of sight. Next. Next slide, please. As vacant slots become less affordable, the practical issues of storing dead bodies clashes with traditional practices. Especially in Japan, religious customs failed to adapt to new high-rise environments. Typical shrine sites in Tokyo, which used to serve the surrounding villages, are now squeezed between soaring apartment blocks. Skyrocketing real estate prices force Tokyo residents to keep ashes of the dead at home or relocate them out of town, putting cemetery traditions at risk. Next. Typical graveyard lots in Tokyo are usually small and fragmented, which makes it impossible to establish a large spanning cemetery or expand in the place of existing one. An exception to this is Aoyama in downtown Tokyo, the largest cemetery in Japan and the one in desperate need of expansion. Next. Many skyscraper graveyards proposed before are merely over-engineered high-tech storage facilities with no connection to burial customs. Our project, on the other hand, aims to seek an alternative solution and replicate an experience of a small shrine courtyard, a space of reflection, abstraction from the busy city life, and a cost-saving solution. Next. The idea behind the design is embedding graveyard terraces into a continuous upward landscape, inspired by similar cemetery arrangements in rural mountainside temples. This investigation concentrated on local landscapes, pagoda multi-like typologies, and the intersection of spiritual space and mountain environment. Next. Unlike regular floors or of burial storage facilities, each panel of the tower is a full outdoor garden where families can rent floor space if utilize it exactly the way they would use a real plot of cemetery land. Next. At the same time, the breaking of the terraced landscape into separate mini parks oriented at different angles allows to gather a small community and foster local ties within the occupants of the block. Next. An efficient and centralized organization optimally directs the flow of visitors. Connecting these courtyards in spiraling fashion at 60 degrees guarantees maximum stacking with unobstructed sky view in order to replicate the experience of a real hillside cemetery. Next. The massive graveyard infrastructure is served by lower floors where ceremonial rooms and crematorium are located. Another advantage of stacking up burial capacity in a tower is that the crematorium complex may efficiently use a significant supply of burial waste to produce heat for the surrounding areas, as has been done in other crematoria worldwide. Next. To secure against earthquakes and typhoons, the tower structure is inspired by the architecture of traditional Japanese temples, which adapted to earthquakes in two ways. In the center of the tower, as seen on the left, there was a solid structural column, shimbashira, which oscillated with the rest of the temple and prevented the tower from resonating. Second, individual sections of a temple were also mounted on movable panels and could also shift relative to the tower, which prevented the failure of individual structural components. A similar approach has been adopted in Tokyo's Skytree in the middle, a 600-meter broadcasting tower. The structure of the tower involves the core column and a series of circular fluid dampers along the height of the tower that prevented it from colliding with the surrounding skeleton. Next. Each floor platform has 3 connection joints with the rest of the structure and in fact distributes the load away from the central vent, at the same time being a part of the larger flexible aerodynamic structure as being exposed in our case. Next. Thus, the vertical graveyard tower combines all 3 techniques. First, it makes use of the core column with a series of dampers, as well as 2 exoskeletons, with the former one being more rigid and responsible for the overall structural stability, and the latter one being more flexible and allowing individual floor caps to oscillate with the wind or the earthquake, as is done in Tokyo's Skytree as well. Next. The design innovation that we propose is to leave the core column exposed and decorated with sculptural finish. Next. The spiraling composition of the tower means that it can be traversed along a route that passes through all sides of the tower. In the event of heavy rain with a wind incident on one side of the structure, the water runoff will be directed along the rest of the tower, thus efficiently allocating the water for irrigation. This is an important part for evacuation as well. Next. We'll talk a little bit more about the site. The suggested site is a semi-vacant lot adjacent to Tokyo's Aoyama Cemetery, formerly a mix of a parking lot, a small garden, and basketball playgrounds. From the one hand, the tower is a natural visual vertical continuation of the cemetery and connects it to the appendix, the graveyard appendix on the left. From the other hand, the green pagoda-like tower structures resonate with the parks and the tall shrines to the north, and finally continues the poetics of green platforms of the nearby 2020 new National Stadium. Next. Having considered a drive-in from major streets and the park to desaturate visitor flow, we propose the tower to become a focal point of the cluster of green spaces, and communicating well with the high-tech downtown and the historical site reinforce the image of Japanese architectural maturity. Next. Finally, we considered some economics behind the development. Given that the tower is comprised of 20 levels, which is 2 platforms each, the total available graveyard area sums up to 85,000 meters squared. Given the construction site of approximately 10,000 meters squared, the tower is 8 times more efficient than a regular cemetery. Considering the total area of Aoyama Cemetery as 215,000 meters squared, the tower complex expands the graveyard's capacity by 1/3. Considering typical Tokyo land prices and construction costs, we estimated the project to be worth $2 billion, which is still less than the estimated $3 billion lost by acquiring a land 8 times larger than the building site. Even though the mega project, the project is a mega structure that is meant to carry certain monumental qualities, the concept of an exoskeletal graveyard structure may instead become modular. Similar tower structures, which could be shorter and easier to build, as seen below, would fill the narrow site of family temples in residential areas, becoming hybrid temple graveyard nodes that would efficiently address the demands locally within the city. Thank you.
Okay.
Great. We'll now begin the question and answer session again, whenever you are ready.
Great. Thanks very much, Nikita. That was a very compelling proposition. I must say, I like the way you drew on the cultural as well as the structural prototypes of the traditional Japanese temples, as well as the cultural norms which are expected in burial in Japan. But I did also wonder in terms of, and I thought it was quite an elegant solution. I just wondered how applicable it might be to other building types and whether you'd considered that as part of your study. But I did also wonder about the materiality as well as the structure and the servicing. There's a lot of servicing required for aerial gardens in terms and the load, the dead load of all the planting, as well as the water management and the microclimatic requirements of plants. Did you actually think about the different aspects and the different winds? I mean, you've cited in a specific location. So did you think about the particular microclimatic conditions as well as the regional weather conditions?
Yeah, thank you. You're pointing to a very important part of the project. We actually could have considered better. One aspect that we talked a lot is I guess in this area is not as much the temperatures, but the winds, which reach out to, I guess, 44, if you think the number is correct, 44 meters per second. And in this case, we had a very a debate regarding whether we need a curtain wall, a more defined curtain wall, because now we have an exposed skeleton. And the conceptual idea was that these gardens have to be exposed, and you have to have some open sky above you to reinforce the concept. Yeah, you're right. It will require a lot of servicing, and we did consider the irrigation part a little bit, but hopefully the aerodynamic shape will, and the windows that are semi-windows and semi-reinforced walls would shield and retain the microclimate inside.
Helen, if I may just pick up on your question, and Nikita, I very much appreciate the narrative of your presentation. As you know, much of what the general public will see, and you talked about the proximity to the National Stadium, would be the underside of the decks. So I'm wondering if you could clarify Will they be clad? How will they be clad? And what their appearance will be like when you're below looking up at them?
Sorry, could you repeat? You broke up for a second. What would be?
The cladding material on the underside of the parks, on the underside of the decks.
That we didn't consider too much, I guess.
Are they poured concrete? Is that the idea?
Do you mean the floor, the levels, floor levels?
The soffits.
Okay. Probably, but we didn't consider it too well.
Nikita, I'll just take on from there. I think it was a really interesting proposition. From a city point of view, as we densify, cemeteries take up an extraordinarily amount of our public space and our open space. So I think the idea of verticality is a very important discussion in this realm, but people don't often want to talk about it. I was just wondering, when you showed some of the little vignettes of the spaces within the layers, that you still kind of moved back to the standard vernacular of the proper gravestones. Was there any discussion of sort of embedding, you know, plaques or eco gardens where little plinths are just buried underneath planting, as opposed to the traditional sort of graveyard looking outcome?
So yeah, I guess I have to clarify when we, so I guess it also relates to previous questions. When we talk about the graveyard, it's mostly ashes. So it doesn't involve dead bodies being stored underground, which already offsets a little bit of this load. So it doesn't have to be a pod of like earth or ground, but more like also like a storage box, which is covered with some grass finish. So I would say in this regard, given that the high amount of servicing that's required to sustain a garden, especially a vertical garden, we minimize the grass area as much as possible, being restricted to pods or maybe like any sort of storage units that would contain those plants, as opposed to having a more expanding garden solution.
Great. Thank you all for your questions on this round. That concludes the 5 minutes for the question and answer section. I will have you all turn your mics and cameras off, and then I will begin sharing my screen for the next presentation, Sky Alley. Whenever you are ready.
Okay. Hello everyone, I'm Heejin, and the next thing I will explain to you is the Sky Alley, and it is an attempt to create a neighborhood lifestyle in the air based on the concept of protecting traditional lanes and alleys. Next. Okay, next please, thank you. Okay, I will explain to you in 3 parts. The first is the background of the Sky Alley. Second, what is the meaning of Sky Alley? And the last, how to realize it. Next. Okay, next. And when 10 years ago, Hutong, the Chinese traditional alley, is an urban space full of life. Different from modern cities, it has its own unique living atmosphere and rhythm. Next. Next, please. But now, more and more historical alleys are transformed into tourist streets to enhance their commercial value. Next. And those blocks with no cultural value will be demolished because the houses are ruined. And the problems also came. Many residents who originally lived here can't accept the living mode in high-rise building. And many scholars believe that the demolition of these traditional alleys will gradually disappear the memory culture of the city. Next. Therefore, Sky Alley is to propose a concept for these problems. Next. Okay, next. And this is a graph that describes the number of high-rise buildings, the number of traditional streets, and the aging trend in Beijing in China. Next. And what we want to do is to put the three in a balanced trend through the design of Sky Alley. Next. And when we found that the scale of two-story residential building was similar to that of traditional Chinese alleys, we decided to try to integrate it into high-rise buildings. Next. Okay, and how to realize it? Next. Next. The project is located in Dongcheng District, Beijing in China. This is the area with the most traditional alleys and lanes and the most demolished areas. Next. It is a live photo. It is now a mixed area of traditional buildings, high-rise, and public buildings. And it was originally a traditional block, but it has demolished. Next. These are the textural distribution. These are the textural distribution of traditional buildings, multi-story and high-rise buildings in the current site. Next. Next. And in site plan, on the one hand, while allowing the building blend into the site texture, we also want to allow the traditional alleys to continue vertically. Next. And we determined the space needed by analyzing the behavior patterns of various age groups in traditional alleys. And we conclude that the space which these residents need are communicating, sharing, self-operated shops, planting, and working. Next. At the same time, we made some changes to the courtyard space, restoring similar living space in the tall buildings. Next. These are the images of the space. Okay, next. In this picture, we can see the composition relationship of each functional space. One side is mainly residential unit space, while the other side is just some shared activity space to meet some lighting needs. And they are connected by a work system named Sky Alley in the middle. Next. In the section view, we can see that the traffic lines of these Sky Alley are connected together. They are composed of several different functional layers to form several area neighborhoods. Next. These are functional floor plans. Next. These are composition relations of each space and structure. The structure is divided into three systems. One is the ordinary frame shear wall structure. The other is the evolution of a traditional Chinese structure formed to support overhanging corridor. The last one is the metal truss structure to support some sharing space or sky garden. Next. And these are some space renderings. Next. Okay, next. And at the end, there is a summary. Sky Alley is a new interpretation of high-rise public transportation space, and it also directly responds to how social issues that traditional alleys are gradually being covered by high-rise buildings, and the memory of the city is gradually disappearing. And I think my explanation should be over. Thank you.
Great, now we will have all the jurors turn on their mics and cameras to begin the Q&A session when you're ready.
Okay, so thank you very much, Hee-Jin. I love this proposition in the sense that you really looked at and understood the urban morphology, the hutong, the social condition, the pattern of uses, and you really tried to interpret that or actually reinterpret it in a contemporary way and understood the content of neighborhood as well as the structure of the neighborhood. My question really is about the flexibility. I mean, I wasn't quite sure what the structural envelope was and the elements within it, and how much ability there is to change and adapt over time, as you would in a normal sort of small scale, fine grained neighborhood where there's individual ownership.
Okay, for the structure, I think I couldn't think the structure for so. I think the structure in the future. I think when the material and the technology would be modern. I think the structure in Chinese traditional structure can be reformed and can be translated for other form to. Okay, I'm so sorry, and I couldn't think the structure problems. So.
Okay, but do you imagine it being a sort of superstructure in which there are modules which are inserted and that is more flexible, or is it all a fixed system once it's built?
When I think
okay, that's okay. I'll look at it.
Sorry.
All right, don't worry. Maybe just to mix it up with Craig.
Yeah. No, thanks for that. That was good stuff. To my mind, it got this minimalist feel about it, which is something I find quite compelling. The materials that are used, though, how much consideration was given to sustainability? Was there a lot of thought given to the type of materials that would be used in a sustainable and regional context?
Okay, I think there are 3 materials in here, and it's just modern material, and it's we can see everywhere. And the material, I think, it's not the key, and it's not the most thing in my plan. And I just think of what's the significance of the protection to traditional blocks, and why I should do that, and what's the plan to protect the culture in our country. And so material and structure is I just couldn't consider it so greatly.
Okay, understood.
I have a quick question, if I may.
Okay.
One of the characteristics of the hutongs is the configuration as cells, meaning that they are usually housing that are arranged on a perimeter of a courtyard. Now, where and in between those blocks, then there are the alleys to connect one part to the other. I was wondering whether in your design you have given consideration to this very important and significant place that was the sharing facilities of a specific community living in that hutongs. How does this translate into your alley proposal, Sky Tower?
Okay. I think architecture is just a container. It can contain people, culture, space, and even the time. And when I think the Sky Alley, I just want to do how to create a traditional life mode and in a modern living space to let the people who originally live here can feel the same atmosphere in this modern living space. And the key to continue the traditional culture, I think, is the people. So I think people is the key to connect the culture and the architecture and the space. I don't know if I have answered the question.
Abby, do we have any more time for any more questions, or have we run out of?
We did run out of time. That concludes the 5-minute Q&A for this project. You can all turn your mics and video off, and we'll begin the next one, Replugged.
Thank you for that.
Thank you.
Am I audible?
Yes.
Firstly, thank you CTBUH for this opportunity. I'm Urmi Panchamya, presenting on behalf of my team, Janam Jan and myself. I'm very grateful to be presenting in front of this wonderful panel. Next, please. Delhi is going through a rapid growth of urbanization and industrialization. We've selected Delhi as our site for the intervention due to multiple reasons. In this process of industrialization, it experiences a huge spike in its air quality index. Next. Where some monitors maxed out with a rating of 999, making the air extremely hazardous. It's alarming that this, unfortunately, might be the future of our cities also. Next. As the region gets shrouded with a haze of carbon, the farming community suffers. The farmlands yield black and rotten crops due to foul air and are also susceptible to flooding. They make irreparable losses, putting the farming community at a threat of extinction. Next. As you can see in this receding agricultural land map of Delhi, how the farmlands have drastically decreased over the decades. Next. Talking about the current situation, crucial times make us realize what we essentially need and miss out on. House confinements and lack of any physical movement have increased trauma and stress. People living in towers feel the most isolated and have lost connection with nature. Next. So the idea begins with questioning, can architecture protect our community? Can it revive the air quality and protect the well-being of its users? Next. Replugged is an attempt to use architecture as a medium to fill this void. Next. It intends to rethink this urbanization as an opportunity to grow sustainably and help the residents and farming community of Delhi. Next. Talking about the farm development, the central core connects the three towers, forming a loop of interconnected activities and spaces. It engages people in a social and experiential way. Next. And aims at bringing back the forgotten nature. The design reimagines a vertical approach to the otherwise horizontally spread out farmlands, mountains, lakes, and lush forest. Next. Next, please. Yeah. So, understanding the zoning, the towers are briefly segregated into residential and commercial zones. The upper half includes a more private zone, which are the residential apartments, and the lower half comprises of the commercial sector and lodging facilities. The central core acts as a cultural band, bringing the programs together. Next. Talking about Tower 1 in detail, we've provided a vertical farm in the core, below which are the research laboratories to monitor ecosystem stability in the premises. It also acts as an exhibition space for visitors to create awareness. Next. Next, yeah. The vertical farms give community new hope and opportunity to sustain in the city centers. The market activates the space where people meet and interact in a process of exchange. As you can see in this view, the farmers, local residents, research and students come together on a single platform. This in turn integrates the farming community into the urban fabric, thus making this space free from labor exploitation. Next. Tower 2, a green amphitheater facing the performance deck is provided in the core. Next. The performance space is designed to give people a more serene outdoor experience, providing opportunities for social engagement and collaborations. It promotes bonding of communities and helps combat loneliness and isolation. Next. The central core in Tower 3 includes a mountain range focusing on physical health and well-being of the users. Next, please. The design takes inspiration from nature in keeping people fit and active. As you can see, the users can get involved in multiple activities. They can climb mountains, zipline across the towers, or simply jog across the track which flows around the mountains. Next. Ecological strategies adopted in the tower are as follows. Next. Biological and digital responsive skin. Algae skin is an innovative photosynthetic system developed by Ecologic Studio. Algae is filled between ETFE. It provides passive cooling while producing oxygen of up to 2 kg, which is equivalent to 25 large trees. Understanding the view, relaxed form of the connecting bridges allows to maximize sunlight internally to the core. This also helps the algae skin to photosynthesize at its highest efficiency. Next. Waste management and water harvesting. Trash collected from residential apartments and commercial buildings will be treated by composting. The organic matter will be used as manures in vertical farming. The biogas released will be converted into fuel and electricity. The storm water is harvested and used in farming. Next. Now understanding the structural system, mega columns and secondary frame make the structural core. The 3 horizontal exoskeleton system connects all the 3 towers of digrid members to each other from the core, generating the void in the center. Next. Lastly, crucial times make us question what architecture is. Is a skyscraper only for its iconic impact or for its holistic and pragmatic abilities? A sensible and sensitive approach towards the built environment, where architecture is an expression of community and an extension of life. Thank you. Next. Yeah, thank you.
Okay. Thank you, Umi. That was a great presentation. I was very taken by your proposition about the air quality being very dangerous. I mean, for any of us who've been to Delhi, especially when all the crops are being burned at the end of the season, it's incredibly, I don't know, discomforting, I suppose, would be the only way to describe it. But I haven't heard of the photosynthetic skin in this sense, and I was just wondering, had you done any modeling to see, so that seeing as that was your very first statement about how you really wanted to tackle this, and then you've put in a whole lot of fairly recognizable methods of dealing with a more sustainable, livable future. But the air quality is a kind of the nub of your thesis. Have you done any modeling on whether you actually have got the surface area or the quantum required to actually make a significant impact, or is it just cosmetic?
The algae skin, it actually transforms the cladding system into a bioreactor. So it takes the existing architectural technology, that is the ETFE cladding system, and it readapts it to host microalgae. The sunnier it gets, the algae grows faster, and eventually it starts actively producing oxygen.
Right. That's fascinating. Okay, great. James or Leah, seeing as you missed out last time.
Thank you very much, Jermaine. I very much appreciate the thought and the thinking and the presentation. And I see that you've organized the building into 3 zones, with the middle zone being that zone which has a lot of the green programming. I'm just going to pick up on Helen's question. In terms of the biological skin, is that seen as something applying to just that middle section, or is that something that you're cladding the entire buildings in?
It clads the entire building.
Yeah, I mean, that was a really great presentation. I think the idea of social, cultural and environmental responsibility came through really strongly. And I think the vertical urban farming is an idea we don't often see taken that further step in mixed use buildings. So a lot of the other uses are often put together, but that's definitely a step in a complete community direction. So yeah, I guess mine is more of a comment that I think from the closed loop energy use as well, I think you've really quite holistically thought about all the components of the building, which is really great. So yes, more a comment, less a question.
Thank you so much.
Craig.
Yes, no, thank you for that. That was very good. As James has already mentioned, and as we saw, there is the clustering of a lot of the vertical farms in the middle of the building. What was the driver for putting it in the middle? There is an argument it could have been at the top, or dare I say, an argument you could put it at the bottom. And I just wondered what your team, what were the drivers in thinking, yeah, we're going to put it in the middle? Just explain that a bit more.
The idea behind putting it in the middle was connecting the 3 towers right in the center at the core. It also helps bridging the private section that's above the residential apartments and the commercial and the lodging facilities that are on the lower half. So it's a way to bridge the programs.
Wow, very good. And if I may, in terms of the proportion, you saw there was a diagram that had the ratio of residential, commercial and farming. Was there any consideration given to the amount of farming? I mean, was it thought through in terms of the amount of food that might be generated and as a ratio compared to the number of residents as opposed to the number of commercial? Was there much thinking given to that?
The idea was to, bring the farms in the city center and also to attain self-sufficiency in terms of food, at least for the premises.
Yeah. Okay. But in terms of the area or the volume that was defined for the vertical farm, was there any sort of logic to that, or thinking in terms of what could be produced?
The soil farming and hydroponics both are used, and also yes, that's why a significant amount of area was given to the vertical farms.
Okay, thank you.
Great, thank you all so much. That concludes the Q&A session for this project. Next, we will begin Medi-hubs. And then whenever you are ready, you can begin.
Sure. Hi everyone, I'm Karan from University of Calgary, Canada. I'm here to present my project called Medi-hubs, which is an ongoing exploration of finding solutions to deal with the ongoing pandemic. Next, please. Sorry. I would like to start with this quote by Robert Swan, the first person to walk to both poles. How he mentions how our ongoing approach towards our planet has changed. Next, please. The year 2020 has taught us that everything can end tomorrow. We need to focus on what is important to us and how as a society we can save humanity. Next, please. With that said, I would like to bring your attention towards some of the world's most developed nations. The numbers you see on the screen represents, next please, hospital beds per 1,000 people. And these numbers are actually terrifying. Next, please. Markets around the world would not be able to make enough room for all the patients who become ill with COVID-19, even if they could empty their beds of other patients. Next, please. Our current solution in terms of responses utilizes converting large auditoriums and stadiums into mini hospitals, which is not safe and ideal at all. Next, please. In most scenarios, vast communities in America are not prepared to take care of the COVID-19 patients showing up, and thousands of people are dying in the States every day. Next, please. The map shows different scenarios of spread of the virus. Even in the best case scenario, with cases of coronavirus spread out over 18 months, American hospitals' bed would be 95% full. Next, please. Nationwide, the difference between a pandemic that takes 6 months and one that takes 18 months could be the difference between health systems that are stretched and those that are completely overwhelmed. Next, please. The challenge may be especially severe for critical care services, where demand is expected to outstrip the capacity at even greater rate. These types of services are also harder to scale up because they require both specialized staff and expensive equipment. Next, please. I believe small design inputs can play a major role in being more responsive towards such conditions for the future. Next, please. For the same, we need to come up with a rapid deployable system. And I looked into shipping containers, which are actually present worldwide. And it turned out that around the world, there are more than 64 million unused shipping containers. Next, please. Moreover, mass transportation of these units is already being efficient worldwide. Next, please. The idea is to transform container ships, which are not in service currently due to a halt in global trade, into hospitals stocked with medical equipment, providing more spaces to treat patients, not to mention added privacy. This also helps boost access to medical care as the ships can be deployed to different areas. Next, please. The structure will respond to underutilized site conditions in the city. Next, please. With its placement depending on the active cases that are around. Next, please. Modular healthcare systems will then be deployed. Next, please. Which will form the central core for all the healthcare activities. Next, please. The core comprises of pre-stressed 4 panels. Next, please. Which are suspended using cable ties in order to feed in the shipping unit. Next, please. Modular shipping containers will then be transported to the site using ships. Next. Using pick and place techniques, these units will be fed into the central core. Next. The great thing about these containers is that they come in different sizes and can address to different needs. Next. Moreover, they can be modified to perfect size for single intensive care bed treatment or quarantine units, providing privacy and comfort. Next, please. Adaptable floor configurations consist of certain corridors around with a ramp accessibility to all the floor plates. Next, please. The central core comprises of vertical circulation lifts and emergency exits on one side, where the other forms the base of carrying out medical needs and activities. Next, please. Overall, the building also connects with the site, providing connections throughout the outer world, which can be considered as an essence in process of healing. Next. Medi-hubs in all is a rapid deployment healthcare skyscraper designed as a response to the current coronavirus pandemic. Next. It also takes into account how healthcare architecture can also be a part of city skyline and break the notion of hospitals just being mere boxes of concrete and steel. Next. These modular robust shipping containers will be stacked with a manageable number pertaining to the next. Medical, next. Treatment, next. Structural, next. And recreational needs. It is important there's a sense of well-being with all needs pertaining to the health of the individual. Next. The structural configuration utilizes steel as the main material. Next. With upper and butterfly pin connections allowing the containers to attach to the main structure. Next. The floor and the roof wall conditions of the containers are also optimized in order to have habitable conditions for all the patients. Next. The aim is that they can be quickly deployed in cities around the world, promptly responding to the shortage of ICU spaces in hospitals and spread of the disease. Next. Ramps acts as a major circulation spaces, allowing access to spaces in case of emergencies or power breakdown. Next. The shipping containers are adapted by removing one of their steel doors and riveting a perspex panel in its place. This allows a solid transparent plastic thing which allows natural ventilation and also as a built-in air conditioning unit. Next. The overall process aims to improve the efficiency of existing solutions in the design of field hospitals, tailoring them to the current or future pandemics. Next. The coronavirus pandemic is forcing us to consider how we live, what and how much we consume, and how to practice resilience. Next. To conclude, the virus has taught us a lot, and the design and architecture industries have to start acting proactively if we want to avoid these circumstances in the future. Next. With that, I conclude my presentation. Thank you everyone for joining us.
Okay, thank you so much for that great presentation, Karan. I've got actually so many questions, but I'll try not to hog the time. It's such a compelling proposition. Did you only think of it as having an application to this emergency? I mean, why wouldn't you think about other kind of building types, as residential building types, or did you think it has application more widely?
It has in the future, but like my main focus was that how you can actually first get the people healed somehow, and then in the future these units can be transported and become residential units when there's no pandemic in the state. But the first and the main need right now is to how you can provide beds if every one of us has a COVID thing going on, how you can be more accessible to those needs. Because if you look at the statistics, like ICU bed will cost around $50,000 per day, and that's a lot for the people. So the aim is also to somehow reduce those amounts in terms of providing more habitable units and more accessibility to these needs, which can be helping in saving lives throughout.
Okay, so and you also have this sort of columnar structure, and basically it's a plug and play sort of approach. Is that just standing there at the ready, that sort of structure and ready to be mobilized with all these containers when a pandemic occurs, or is the whole thing kind of shipped in the state of an emergency?
I think the idea is to somehow, like the core will be made in matter of weeks, but the shipping units can be deployed quickly because the core is actually made of steel structure, which is modeled on site, but the units will be prefabricated so that there's always a base common which is going throughout the sites, and it's just a matter of the crane picking up those units and putting back in.
Okay, and then I noticed it was a very sculptural form in the sense that most containers are quite orthogonal, and so you had a sort of a chamfered plug-on sunshade sort of, I don't know what that window system is. That what we were seeing, or?
Yeah, the window system was basically to somehow provide views to the city, and moreover, capture the conditioning and all the services which are required for these biocontainment units in order to access and moreover provide hospital needs requirements to that. Because I do agree that if I try to convert all these units into habitable, that might be impossible. So maybe there's a way of plugging in one unit which carry all the services in directly into those shipping containers, so that the process of these manufacturing things can become easy and not that much time consuming.
Okay, I've asked too many questions. Viviana or Craig or James, Leah, it doesn't really matter. I know we won't have enough time for everyone to ask questions because
I'm gonna just touch on what you just try to get clarification on, and is in regards to the former final appearance of the tower that I think is very interesting. There is this idea of modules that are somehow pitched or adjusted with this nosing system that goes into the container that is the part that is customized. And you did said that the different nosing will be adaptable to different views into the cities or different maybe lighting conditions. And I wanted just to clarify whether you have done any simulation to look at how the tower will need to be shaped in different locations, not only the one that you tested. Because my understanding is this units, this tower system will be then potentially moved somewhere else.
I mean, it's so like the situation which I've showed, actually it's like an ideal situation, because given the different shape and sizes of the units, the tower shape can actually habitat with different needs of the society, pertaining to if the tower is present in New York or whether the same tower is present in San Francisco. But the bigger goal is that most of these towers won't have the same shape. It will just depend upon which shipping containers are being transported quickly, which sizes are there, and then they can be plug and placed into the tower. So it also opens up different iterations of the form of the tower. But the situation which I've shown is like kind of one of the ideal situations, which how the tower can look like.
Great, thank you all for sharing. That does conclude our Q&A session. I just wanted to touch on a few things and say thank you everyone for joining this year's CTBUH 9th Student Design Competition